Okay, here we're going to look at problems from section 7.3, multiplying and dividing rational expressions. And really a lot of this comes down to factoring. And I know everybody's favorite topic is factoring. And so you're looking for factors in common that we can divide out, because anything in common, and what I mean by that is you have the same factor in the numerator and denominator, and anything divided by itself is 1. And we know when we're multiplying, right, we can multiply straight across. So in essence, we can make this one large fraction symbol if we wanted. So I look at this first trinomial here, and I see I can factor a 7 out of each term. So I'm left with m squared minus 3m plus 2. And I look over here, and I can see I can factor out a 6m. And I'm left with 5 minus m. And then here in the denominator, I see I can factor out a 2. And I'm left with m squared minus 2m minus 15. And here I can factor out a 7, and I'm left with m minus 1. Okay, so here I have another trinomial still left. Two numbers that multiply to 2 and add up to -3 would be -1 and -2. And again, because our leading coefficient is a 1, that makes that one pretty easy. Here, one of the things I see, well, I'll leave that for a little bit. We'll come back and talk about that in a second here. Here in the denominator, again, I have a leading coefficient of 1. Two numbers that multiply to -15 and add up to -2 are -5 and 3. So I have m minus 5, m plus 3. And then over here, we have 7 times m minus 1. So looking at factors in common, I have an m minus 1 and an m minus 1. And let's see, I have a 7 and a 7. And then I have 6 and 2. So 2 divides into itself 1, into 6 3 times. And now I look and I see I have an m minus 2 and m plus 3. Nothing I can do there. I don't have any m's in the denominator to go along with that m. But notice here I have an m minus 5 and a 5 minus m. And so those are what we would call opposites. And so that divides out or equals -1. Another way to look at it is I can factor a -1 out of these terms, and that becomes positive, that becomes negative, and so we're left with m minus 5. And there it is, they divide out, and notice there's your -1. So now in our numerator, I'm left with -3m times m minus 2. And in the denominator, the only factor left is the m plus 3. And it also wants us to state excluded values, so those are values that would make the denominator 0. So we look at the different factors. So m cannot equal 5. -3, or here 1. Okay, so now over here, let me draw a little separation line here. Okay, so this one, there is no common factor. And so I'm going to show you a little something. I'm not going to factor that one yet. We're going to come back to that in a second. And I'll tell you why, a little trick, but we'll do this independent as well. So I see here that I can factor out a 2 from both terms, and we're left with 5b plus 2. Now notice we're dividing. So when we divide fractions, we take the reciprocal of our divisor and multiply. So I'm going to flip that second term, this rational expression, and I'm going to factor it at the same time. So I can factor a 2 out, and I'm left with b minus 7. And here I can factor out a 4, and I'm left with 2b plus 3. Okay, now here's one of the realities in many problems that are designed, whether they're in textbooks, quizzes, exams, right? The point of all of this is to simplify, right? We're dividing, which means we're going to factor and find common factors. Well, notice here I could factor out the 2's, but here I'm left with this. And I know that I have to factor that. Well, look at what we have in the denominator. We have 5b plus 2 and 2b plus 3. Well, that looks like those two could be factors of this, right? 2b times 5b is 10b squared. 2 times 3 is 6. We'd have to figure out, does our middle term work? So you can use that as a guide, and pretty good chance that you're going to find some of these factors down here. But let's go back and let's just review a little bit. I'll do it down here. We'll do a little bit of independent. How do we factor this? So we have 10b squared plus 19b plus 6. All right, so no factors in common. So we're looking for two terms or two numbers that add up to 19. And those same two numbers have to multiply the product, 10 times 6, of 60. So we look at our factors of 60, and we should be able to come up with 4 and 15. Okay, it doesn't matter the order. So we're going to split our middle. I'm going to put the 15 first, so 15b plus 4b plus 6. Now I can factor a 2 out of those two terms, and we're left with 2b plus 3. We know in order to use our grouping method, this has to factor so that we're left with 2b plus 3. And I can factor out a 5b. So there's the 2b plus 3 we have in common. Factor that out, and we're left with 5b plus 2. Well, that's exactly what we had up here. So it confirms that, and we do need to be able to do this factoring independent. But again, we can use what we see here as a guide. So now, going back and looking at that numerator, we have 5b plus 2 times 2b plus 3 divided by 2 times 5b plus 2 here. Okay, so the 2's divide out, the 5b plus 2's, the 2b's plus 3's, and we're looking for values that we have to eliminate. Now it gets a little tricky here, so a couple of things. So we're left with the b minus 7 over 4. b cannot equal. So a couple of things. We need to take into account this original denominator as part of what b cannot equal. So even though we had to flip it, right, that's still part of our values because it is a denominator here. So b is not allowed to equal 7 because that was from there. Here, this one that makes that equal to 0 is negative 2/5, and that's negative 3/2. So there's two problems multiplying and dividing rational expressions. I hope that helps, and we'll see you soon.